So here we have a blood gas, pH 738, PCO2 21, and a bicarb of 11.7. The first thing we always want to do is look at the pH and see if it is acidic, basic. Is it acidic or alkalosis? 7.38 falls on this side of our balancing beam. And as you can see, the exact balance of normality is 7.40. Anything less is acidic. Anything higher is alkalotic or basic. Here we have 738. So we define this as an acidosis. A-C-I-D-O-S-I-S. 738 is 100% normal. It's within our normal range. We'll go down to 7.35 and have a normal blood gas with a degree of acidity to it. CO2 is 21. CO2 is 21. Our normal range for CO2s is 40 to 45 and from 35. Normal CO2. When we get a larger CO2, we become more acidic because CO2 is considered acid. And when we lose CO2, we consider that basic or alkalosis. Here we have a condition where we've lost a lot of CO2, so we moved that toward the basic. So here we have a alkalosis. Bicarb. Bicarb is the base. The normal bicarb is 24, and 26 to 22 is the range. So here we have 11. We've come way down on this bicarb to 11.7. Now bicarb is a base. So when we lose that base, that makes us very acidic. When we increase that base, we become more basic or alkalosis. So this is acidic too. Now let's take a look at these three things: acidosis, alkalosis, and acidosis. So first off, two match up, which means that this system, the metabolic system, is the controlling system here. So here we have a metabolic acidosis. The next question is it partially compensated or fully compensated? Since the pH has come back into the range, which is a normal range, we'll call this a fully compensated metabolic acidosis. If the pH did not return, and say the pH was 734, then it would not be a fully compensated metabolic acidosis. It would be a partially compensated. It's partially compensated because our bicarb has dramatically shifted. And our compensation mechanism is the respiratory breathing centers. In order to balance this metabolic acidosis, there's something going on in the body that's producing the acidosis, perhaps an infection, perhaps a hypoxia. The CO2 system is blowing off its normal CO2 to lower it to balance that out. So fully compensated respiratory alkalosis, let's look at that. Is it a fully compensated respiratory alkalosis? Is this an alkalosis? No, it's an acidosis, so we can rule that one off. Not a fully compensated respiratory alkalosis. Partially compensated metabolic acidosis. It is an acidosis. It's metabolic, and it is partially compensated. Well, it's moved it back into the range, so it's fully compensated. It is not partially. Acute metabolic acidosis is an acidosis. It is metabolic, but we have a compensation mechanism going on because our CO2 has moved from a normal of 40 down to 21, so we are compensating, so it is not acute. So we'll cross that one off. Leaves us, by process of elimination only with fully compensated. But we could go the other way around and say, is this fully compensated metabolic acidosis? Is it an acidosis? Yes. Is it fully compensated? It's moved back into the range? Yes. Is it metabolic? Yes. So this is the one that is the correct answer. All blood gases are looked at the same way. What is the pH? Acid or alkalosis? What is the CO2? Acid or alkalosis? What is the bicarb? Acid or alkalosis? And then, whichever lines up right is the system that's causing it. This is that one question we wanted to talk about. Thank you, and use your hand sanitizer. 70% alcohol.